All right, let's talk about the outlier effect. We're going to dive into why that simple word, average, can actually be one of the most misleading words in all of statistics. So why is that? Let's find out. You know that feeling, right? You see a report about the average salary in your city, and you just kind of scratch your head and think, wait a minute, who are they talking to? That number can seem totally impossibly high, like it's from another planet.
Well, I'm here to tell you that feeling you get, it's not just you, it's real. There's a very specific statistical reason for it, and the whole mystery, it really just boils down to one single fundamental question.
And here it is, the big question. Which measure of central tendency is most affected by extreme values in a skewed distribution? Okay, I know, that sounds super academic, a real mouthful. But stick with me, because understanding this one concept is like getting a secret decoder ring for data. It's the key.
All right, let's start our investigation. First things first, we've got to define our terms.
So, central tendency sounds complicated, but really, it's just a fancy way of asking, how do we find the center of a bunch of numbers? Think of it like trying to describe a whole crowd of people with just one representative. But, and this is the important part, there's more than one way to pick that representative, and that's where things get really interesting.
Okay, to see how this works, let's start with a really simple, clean set of numbers. We've got 5, 6, 7, 8, and 9. Nice and balanced. We're going to use this to look at the three main ways to find the middle.
First up, we have the mean. Now, this is the one you learned in school. It's what pretty much everyone thinks of when they hear the word average. Super simple. You just add up all the values in your list and then divide by the number of values you have.
So, for our little data set, we add 5 plus 6 plus 7 plus 8 plus 9. That gets us to 35. We divide that by the 5 numbers we have, and boom, the mean is 7. Easy enough, right? It's sitting right there in the middle.
Okay, method number 2 is the median. With the median, the most important thing is order. You have to line up all your numbers from smallest to largest. Once you've done that, the median is literally the number in the physical middle of that line.
And for our set, which is already in order, 5, 6, 7, 8, 9, it's super easy to see. You've got 2 numbers on the left, 2 on the right, and what's smack dab in the middle? The number 7. So our median is also 7. So far, the mean and median are exactly the same.
And finally, we have our third measure, the mode. The mode is the easiest one to remember. It's simply the most popular number, the one that shows up most frequently in the list. Now, if we look at our little data set, 5, 6, 7, 8, 9, each number only appears one time. Since no number repeats, there's no most popular one, so in this case, there is no mode, and that's totally okay. A set of data can have one mode, more than one mode, or, like this one, no mode at all. Okay, so right now, in our perfectly neat and tidy little world, the mean and the median are both 7. They agree. But we all know the real world isn't so neat. It's messy. So now, let's throw a wrench in the works. Let's introduce a troublemaker, what we call an outlier. So here's what we're going to do. We're going to take our original list and add just one more number to it, the number 100. See how different that is from all the others? That's our outlier. It's an extreme value that's going to totally change the dynamic. So let's take a quick look at where we started. This is the before picture, a nice balanced data set. The mean was 7, the median was 7, they were perfectly aligned, telling us the exact same story about where the center is. Keep this picture in your mind. Okay, now for the big reveal. Let's recalculate everything with that 100 in the mix. First, the mean. We add up all the numbers, including the 100, and now we divide by 6. And, whoa, the mean shoots all the way up to 22.5. Now, what about the median? We line up our numbers, 5, 6, 7, 8, 9, 100. The new middle is right between 7 and 8. So we find the average of those two, and we get 7.5. Just look at that difference.
And this chart, this says it all, doesn't it? This is the after picture. Look at the median. It barely moved. It went from 7 to just 7.5. It's still hanging out with the original cluster of numbers. But the mean? Oh my gosh, that one single outlier, that 100, grabbed the mean by the collar and dragged it all the way up to 22.5. It's not even close to the rest of the group anymore.
So, this brings us to the verdict. The evidence is in, we've run the numbers, and the case is pretty much closed. It's time to answer that big, academic question we started with.
So, which measure of central tendency gets thrown off the most by extreme values? It is, without a shadow of a doubt, the mean. The mean is super sensitive. One big or small number can pull it way off course. The median, on the other hand, is tough. It's stable. It holds its ground.
Okay, so why should you care about any of this? Because this isn't just a math problem. This is real life. Think about data like salaries or home prices. Those data sets are never perfectly balanced, right? There's always a few billionaires or multi-million-dollar mansions in the mix. So when a news report says the average salary is, say, $90,000, they're probably using the mean. And that mean is being yanked way up by a few super high earners. The median salary, though, that tells you what the person literally in the middle of the pack is earning. And for most of us, that's a much more realistic and useful number.
So, here's the big takeaway. From now on, whenever you hear or read the word average, a little alarm bell should go off in your head. Be a little skeptical. And now you have the power to ask the smartest question in the room. Are you talking about the mean or the median? Because as we've just seen, the answer to that one little question can tell a completely different story.